Thanks, everybody. This is, of course, an image of the Mercury transit, and I'll be saying a little bit more about that towards the end. This was taken from NASA's Solar Dynamics Observatory, so wasn't particularly worried about the weather that we had here, but rather a nice image. But I'll leave all the Mercury transit stuff for the end of this talk. So starting with the Sun. The Sun's actually had a fairly large spot on it on and off now for the last couple of months. This is its first incarnation. This is AR 2529. This large spot here, it was up to about 800 millionths in area, which is quite a large spot, so fairly easily visible with the naked eye. This was it on its first rotation around in April. That's one of Ron's pictures there, and then these are yes, these are a couple taken by some very, very impressive solar images. Dave Tyler's one on the left there, and Carl Barron, and again just an extraordinary example of what amateur imaging can do nowadays, and particularly on the Sun, where those of you who tried to image the transit will have noticed that the seeing on the Sun is not usually particularly good. So to get this kind of quality is extraordinary, but it's a really interesting spot with kind of a bridge going over it here. Anyway, so it went off the disk, went around, came back, went around, and has come back again, and it's just about to go off the disk again. So this is it. I think this is Peter Meadows' picture taken yesterday. You'll have to hurry to see it. It's just about to go over the limb. Probably tomorrow or Friday it'll disappear over the limb. But it'll be worth looking. If you can get the forecast is looking like you might get a view of it Friday morning. Look out to see whether it shows the Wilson effect. So the Wilson effect is this effect where the umbra of the spot is displaced away from the limb. So it makes it look like the spot is in a sort of hollow. And this is a particularly good spot to see that with. Nice big spot coming up to the limb. So look out for that. The Sun itself, of course, affects us in a number of ways, and one of the ways is by the solar wind interacting with the Earth's magnetosphere and then down into the Earth's atmosphere, forming the aurora. And there have been some reasonably good displays over the last few weeks. This is an image of the aurora taken from up at Tarbot Ness, Dennis Brzezinski's site up there. Dennis has had some remarkably good nighttime weather at his site up in Tarbot Ness. It gets very good dark skies, very good clear weather, but it's been bloody cold up there, and I think it hasn't got much above 10 degrees for the last, in living memory as far as But anyway, I can take pleasure from the fact that Dennis can't do any astronomy from up there now for the next 3 months because it also doesn't get dark. So he's going to be limited really to looking out for these kind of things and maybe looking for planets as well. So over the summer we're coming into the season when we can see noctilucent clouds. Last year there weren't really very many displays of NLCs. Dennis got this. This was the first display he saw at the beginning of June, fairly faint display. There was pretty much nothing from the south of England. There were some very weak displays, but nothing like the displays that we've seen of NLCs in years previously. But it's always worth looking out for, and they're a lovely sight, I think, in the middle of the summer, in those lovely June evenings when, 11 o'clock at night and it's just getting into the twilight. If you look to the north and you see these bright white luminescent clouds with amazing structure in them. This is one of Maurice Gavin's pictures taken from London in 2014. Really nice view. Most of the pictures that you'll see of NLCs have Capella. Is it Capella? Yes, it is Capella. Capella in the field of view because it's basically pretty much due north, culminating under the pole at this time of the year. So watch out for NLCs in the summer nights, even if it's not dark enough for anything else. Another thing that's very difficult to see at the moment, or at least we won't be seeing it in our skies, is the planet Venus. So Venus has been very bright, but it's now approaching superior conjunction. So essentially it's going in the opposite way to what Mercury did. It's going behind the Sun, as seen from the Earth rather than in front of the Sun. It's now getting very close. Superior conjunction's on June the 6th, and you can actually see it though in the SOHO C3 coronagraph. It'll be in the C2 coronagraph, which is the smaller field of view, I think by now or very shortly. So you can follow that over the next few weeks. Of course, the other nice thing about looking at the C3 coronagraph is you see star fields that you're not used to seeing at this time of the year. So there you go, Pleiades and the Hyades. So if you're a variable star observer who gets troubled by these terrible solar conjunctions and all of these kind of things, you can actually do your observations from SOHO. So starting in the evening twilight, this time of the year, looking to the west, we've got Perseus and August setting. Looking a little bit to our left, we've got Cancer and Leo. And if we move a bit further left, we come across the one really bright planet that's visible in the sky in the evenings, which is Jupiter. So Jupiter really is dominating the evening skies at the moment. It's past opposition, quite a long way past opposition now, heading towards conjunction at the end of September, but it's still very high up. It's certainly the highest planet that we have visible from our latitudes at the moment, high up in the evening sky and a good imaging target. And as is the way, people have been getting better and better quality images of Jupiter. And one of the extraordinary things is that every year I look at the kind of images that amateurs are getting, and they just get better and better and better, and people are still just squeezing the last ounce of resolution out of their systems. The software now for processing images is very, very advanced and allows you to take very long sequences and stack them up. And also the cameras are now very advanced too, so you can get very, very sensitive cameras. People still talk about using webcams for imaging planets. They're not really webcams. They're very, very high quality imaging cameras that can take very fast frame rates for long periods. So this is a Chris Go image of the red spot, and then here is an animation that John Rogers put up in his recent report, which you can actually see. If you look at this, you can actually see features rotating around the red spot. So this is rectified, so essentially as if you're looking down on top of the red spot. Quite extraordinary that you can do that amateurs can do that. And of course, once you can actually track features going around the red spot, you can calculate wind velocities and do all sorts of interesting science. It's not just kind of the Damien Peaches and the Chris Goes to get really good quality images. This one is from Martin Lewis, really nice image again of Jupiter and Io, taken with a large telescope, a 440mm Dobsonian. But look at the kind of pixel resolution he's using here. He's using a pixel resolution below 1/10 of an arc second. So that really is sort of oversampling the image, very high frame rates, trying to get the absolute ultimate out of what the telescope can produce. And people, of course, now, with modern cameras being so much more sensitive, are able to take images in wavebands where it wouldn't used to be possible to do. So these are methane waveband images, which taken with all the other images and different filters, tell us a lot about what's going on in the atmosphere of Jupiter. So an immense amount of science that amateurs can get now with these images. But visual observing is still interesting and important. This is some drawings by Paul Abel of Jupiter showing a satellite transit. And then with all the images put together, you can actually make maps of the planet. And for anyone with even the slightest passing interest in Jupiter, I recommend you go onto the BAA website at the moment and you read the latest report from John Rogers, just to get some kind of feel for what amateurs can do now in terms of the science that they can get from their images. So, going chronologically through the night, there are a couple of comets you can see in the evening sky at the moment. I'm afraid none of them are particularly spectacular, but this is a comet that's been rather interesting. It was mentioned at the last Sky Notes. This is Comet 252P Linear. It made a very close approach to the Earth. And then, as is the way with comets, it behaved in a way totally different to the way that people expected. It was actually much brighter than the predicted light curve for quite a while. It was a very extended comet, a very diffuse comet, and so to actually see it in light-polluted skies was quite difficult. I saw it in binoculars from dark skies, but it was a very difficult object. But it's still there. It's faded fairly dramatically, but if you want to get a chance to see it before it disappears completely, it's currently on the border of Hercules and Ophiuchus. And just a few pictures of it. This is a picture of mine, taken in April. This is a fairly large field of view. This is over 2 degrees by 1.5 degrees, almost 2 degrees that way, so a large coma. And this shows why it's so difficult to measure the magnitude of an object like this. Unlike the variable star observers, who've got the easy job of just measuring the magnitude of a little point source, comet observers have to somehow measure the magnitude of a big fuzzy blob like that. And depending on your sky conditions, you can get really big variation. I mean, John showed, half a magnitude would be terrible. You'd be shot as a variable star observer, but comet observers would be lucky to get within 2 magnitudes with something like this. Anyway, it's been fading. This is a picture that was taken. When was this taken? On the May the 9th. Yeah, so this was taken on May the 9th. This is Peter Carstens from Leon C. And then very recently, a bit more recently, this is Denis Brzezinski's taken on May the 11th. So it's fading away. But it's been an interesting comet whilst it's passed. Another comet that's in the evening sky at the moment is this one, of course, very famous. This is Comet 67P, the comet that Rosetta is going around. We just passed through the orbital plane of 67P, which means that we can actually see the dust trail that it's left behind in its orbit projected onto the sky. Now, admittedly, these are pictures taken with the Isaac Newton telescope, a 2.5-metre telescope, but amateurs using remote telescopes have seen this as well. And of course, all that dust is coming from something that we now know to be... Hello? Yes. We now know to be this. So this is a great movie that's recently come out. It's not a movie made from images, it's a movie made from a 3D shape model that has been made of the nucleus of 67P and then put into a computer program to animate it. But so when you're looking at that comet, when you image the comet, you know that that's the thing in the middle that's giving out all of that dust. A little bit later in the night, around about midnight, Saturn and Mars are due south. Both of them are down in the far depths of the south, so they're in Scorpius and Sagittarius. So imaging those from our latitudes is pretty hopeless. I had a look at Mars the other night. It was definitely a planet. It was definitely red. It had some vague surface markings on it, but I wouldn't consider it a particularly spectacular planetary observation. You need to go far south to get good images of those, and of course that's where Damien goes. So he goes to Barbados, and both Saturn here, this is a lovely image of Saturn where you can see the North Polar hexagon here, which is a feature that used to be extremely difficult for amateurs to get and is now regularly imaged by amateur imagers, and some really nice images of Mars here. So have a look at Mars while you can. It's will be fairly quickly moving away now. So have a look at it, but don't expect anything great from our latitude. It's very low down. Also low down and sort of struggling along in the murk is this dwarf planet, Pluto, which is in Sagittarius as well at the moment. But there's a good opportunity for finding Pluto on the 27th of June, when it's just south of this bright star, Pi Sagittarii. So you can find that star and then move to the field here to see Pluto. So it's a good opportunity to see Pluto, although again it's at declination minus 22 or so, minus 21, so not very high from our latitudes. And of course we now know it looks like this. So again, an amazing thing. When I taught last year at the last BAA Sky Notes, we were looking forward to this. We now know what Pluto looks like. So from a sort of fuzzy object that was imaged by Hubble, we now have incredible high-resolution images of this dwarf planet. And of course, New Horizons going off to rendezvous with a Kuiper Belt object, sorry, an Edgeworth Kuiper Belt object, because I'm talking to the BAA, in, is it 2019?
January 1st.
January 1st, 2019. Okay, I thought I'd put in a variable star. John's already mentioned this one, but it's well placed for observation at the moment, our Corona Borealis. There it is. This is the crown of Corona Borealis. There's the variable star. This is the star that sort of emits soot, which basically covers up the star. It fades down, and we're now, as John said, in the deepest maxima, and I think we're about, is it a year until we reach the longest known maxima on record? So it sort of made a valiant attempt to come back, and then it's gone back down again. So definitely a star worth keeping your eye on. And then moving around into the morning sky, we've got the constellations of summer appearing, so Cygnus and then down into Pegasus. But of course, as we move into the summer, we get very, very little darkness. There isn't another BAA meeting, I think, with the Sky Notes until September, so I need to mention the Perseids, because this year the Perseids could be quite interesting. The normal maximum for the Perseids is actually at 2 p.m. on August 12th, so that's during daylight here. But there are predicted to be 2 crossings of dust trails from the progenitor comet on the evening of August the 11th, one at 22:34 and another at 23:23. And the predictions of these dust trail crossings have been quite accurate, are quite accurate now for meteor showers. So it's definitely worth looking out for enhanced activity from the Perseids on the evening of August the 11th. The moon's just past first quarter, and it'll be a beautifully clear night across the whole of the UK. So the Perseids are always worth going out for. Lovely weather at that time of the year. Organise a barbecue and then have a Perseid watch afterwards. Okay, so on to the Mercury transit. The transit on May 9th, we were very lucky in the UK because we could basically see the transit from start to finish. It started about lunchtime, about 12:12 BST, and would finish after about, I think it's about 7:40, yes, so 18:42 UTC. So we were in an ideal spot from the point of view of seeing it all the way through. Of course, the thing that affects the transit is the weather, and this is what the weather did on that day. So you can see that the people who were north and east, and particularly the people up here, sort of north of a line from the Wash across to the west coast here, had a completely unobstructed view. Where I was in Chelmsford here, we saw the first few hours of it, and then it clouded over. And if you happen to be down in sort of the southwest or Bristol or around there, you probably wouldn't have seen it at all. But that's a really graphic demonstration of the potluck of astronomy, really, just depending on where you were on that day, whether you had a fantastically good view or no view at all. So in Italy they had a good view. This is from Giovanni Di Giovanni in Italy, and he did some experiments to look for what's called the black drop effect, which for Mercury is a seeing effect, essentially at the point of inner contact, where do you actually get an extension, this extension here. And of course historically that's important because of the measurements that were intended to be done on the transit of Venus, and with all the intention of sort of getting the scale of the solar system. They were wrecked by the fact that you couldn't accurately time this inner contact because of this black drop effect. So this is some nice work that Giovanni did. I mean, from my point of view, I videoed the contact of this, and the seeing was so bad that it was almost difficult to distinguish between inner and outer contact. I mean, the whole limb of the sun was rippling. It was dreadful. But of course these days, one of the things you can do with monochromatic imaging is you can actually see Mercury before it even moves onto the photosphere. So this is a lovely image from Pete Lawrence, who decamped from Chelsea, and you can understand why given the Meteosat picture I showed, and moved to Leicester, to Paul Abel's garden in Leicester. Took a battery of telescopes with him and took this lovely shot of Mercury crossing the chromosphere here before moving on to the photosphere, and in fact being kind of almost silhouetted against a small prominence. So that's really nice. Martin Nobley did a similar thing. So with a Lunt solar telescope, he's got Mercury imaged here. It's difficult to see on this screen, but I can see it on the laptop. It's probably visible there. You can just about see it beyond the photosphere. This is my attempt at doing it, and basically I was videoing the ingress using a high-speed webcam, and these are about the best frames that I could extract. But the nice thing, it shows that the predictions are very accurate. So from my site using Xavier Dubia's transit calculator, which calculates for your particular location, the internal contact was predicted to be 11, 15 and 34 seconds. This is 11, 15 and 33, and you can see pretty much that is right. So it's a really nice example again that mathematics really does work, and that solar system ephemerides are really accurate. A few more images. This is a Mick Crook image from Lancaster where they had sunshine pretty much all the way through. You'll see from this there was one reasonable sized sunspot and a few smaller ones on the disk. This is Peter Carson from Leigh-on-Sea, who apparently had a barbecue and cheese and wine party. So whether people came for the cheese and wine and just saw the transit, but I was told there was no cheese and wine left at the end. So the local Astro Club are obviously very good at drinking wine and eating cheese. So that's just after first contact, inner contact. This is a really nice video by Simon White up in Kendal, so again good views all the way through. And the amount of effort that it is involved in taking these kind of time lapses, where you essentially have to take a regular image. You can see how smooth this is. He was taking images every few seconds throughout the transit and then put them together into a time lapse. It's really impressive stuff. It is good, though, to see it speeded up like this, because apart from the inner and outer contacts at either end, the bit in the middle is really like watching paint dry. 7 hours of seeing an 8 arc-second disk crossing the solar photosphere. This is Mike Harlow up in Ipswich. You had a nice system where you could observe the transit in comfort under a gazebo here with a heliostat and a system projecting a solar image onto a piece of card there. So that's the kind of posh way of observing the transit without having to go to the trouble of doing all this imaging or anything else. This is another Pete Lawrence image taken near mid-transit. So this is a larger sunspot group, a smaller group there in Mercury. And for those who can remember the Venus transits and how big Venus was when it crossed the Sun, I mean, it was really an obvious naked eye object. Mercury really is small, and it gives you a really good idea of how big the Sun is and how small Mercury are. And Mercury's not that small. We're not much bigger than Mercury is. So really good idea of how big the Sun is and how small the planets are. This is Alan Tow in Elgin, so right up the top of Scotland, a monochromatic image, which is always more dramatic than the white light image showing Mercury there, and then a nice white light image that does show the granulation, again with Mercury moving across the face of the Sun. So with Pete Lawrence in Leicester was Paul Abel, and Paul did some drawings. So this is a nice sequence that Paul did, and where they were just north of where the cloud basically came across at the end of the transit. So they actually saw the end of the transit right through till fourth contact. And you can see it going off the disk here. And then Bill Ward up in Glasgow actually got egress. So this is Mercury moving off the disk of the Sun after 7.5 hours or whatever it was of transit. So it was a really nice event. I hope a lot of you got a chance to see it. They're not that rare. They're not like Venus transits, but they're also, interesting to see. Just a few final slides of things. So this is another time lapse. The orientation is different, so this is actually mirror image, but this is by James Dawson up in Nottingham. So he's basically got it all the way through to the point that it was lost into the cloud in Nottingham. This is the SDO image that I showed earlier, and of course there they just have no problem with weather or anything else. And they also have some really good people for processing the images too. So SDO put out some really nice stuff for the transit. This, though, I think is one of the most interesting time-lapse or composite pictures I've seen. On Xavier Dubier's page that shows the transit, of course, Mercury goes across the Sun in a straight line, doesn't it? But if you're looking at it in an Altaz telescope, because the Sun is rising, going through south, and then setting, the actual path that you get isn't a straight line at all, it's a curve. And I saw that on Xavier Dubier's site, and I thought, that's very, very odd. Does it really look like that? Well, David Basie actually did a composite based on his Altaz images, and yes, it does. And I think that's a really nice example of doing something that's kind of different to everyone else, and showing something that, you know, is predicted but different. So that was very nice. So I'll leave you with this. This is the SDO video of the transit. It goes on for a couple of minutes. It's taken in multiple different wave bands. It's taken a very high time cadence and shows an 8 arc second disk of Mercury moving across here, the solar granulation. If you go to the SDO website, you can download this in 4K. So if you've got a 4K ultra high definition TV, this is really, really spectacular. But even on a fairly large computer monitor, it looks really good. So that's it. That's the Mercury transit. Through the summer, don't forget, watch out for noctilucent clouds when you get the opportunity. Look at Jupiter while you can. Look at Mars whilst it's there. Even look at Saturn. Saturn's looking okay, even though it's low down. And watch out for the Perseids in August. Thank you very much.